Welcome back to Critical Thinking, Analysis and Materials to Combat Climate Change. In part two, we're looking at different perspectives on the emitters and the idea of net zero. Is this a realistic ambition? And we delve into carbon capture. Like emissions were 36.3 billion tons in 2021.
Right.
And Canada only accounted for 0.7 billion tons of that. So
that's right.
If someone says, well, why are you hammering on Canada with constant messaging about this and this and this? Wouldn't it be better to focus on implementing change in China, in India, in the developing world? Why is it everyone's picking on, you hear this argument a lot. Why is it we're getting this messaging?
And you're absolutely right there too, Andrew. We sit here and we sort of virtue signal and pat ourselves on the back and say Canada is going to become net carbon zero by X, by a date. Great. Anytime somebody tells me something about a figure becoming net zero, I immediately think, okay, there's going to be an accounting trick happening here.
Yes.
What I want to see would be somebody in Canada saying, okay, we're going to approach actual zero. We're going to approach no human emissions of carbon, which frankly is going to be way, way, way too much work and take too long. I mean, it's the old 80-20 rule.
Yeah.
You know, it's the idea that you can get 80% of the result with 20% of the work, but that last lousy 20% is going to take 80% of the effort. What we should be doing is taking that 80% reduction that we can achieve relatively easily and doing it everywhere on Earth. But the problem with that is, to do it effectively, we're actually going to have to work together as countries, as a society. And man, that's something that we don't seem to be able to do very much of today.
Yes. And one way to kind of jump back just one step, where you mentioned the accounting trip, when we look at captive markets, when we look at, say, carbon capture, because we get both sides get annoyed on this one too. It's a nuanced position of, great. So if we can capture the carbon and either store it underground or some of these machines that can capture out of the air, some people go, that's amazing. This is great. We're going to solve some of the problem. But the other side might say, well, wait a second. This just means we could still keep on going with fossil fuels and coal, because you could game the system that your contribution as XYZ company has been net zero, because you own not only the carbon capture, but you also own the coal plants.
Yeah. I saw an ad down here not long ago, down here in Argentina, about some international airline. It was on one of the World Cup broadcasts. And it was, we plan to be the first net carbon zero airline. And I was thinking to myself, okay, so where are you going to draw the boundary around what net constitutes? Is it all the way back to the manufacture of those big aluminum and composite material aircraft? Is it at the point where you add fuel to the plane? Is it at the point where the passenger drinks a cup of coffee? I mean, where exactly are you going to play this accounting trick to somehow convince people that you're net carbon zero? At the end of the day, if that plane is flying through the air and it's burning a fossil fuel, it's contributing carbon dioxide to the air. And we have to stop thinking about playing accounting tricks and coming up with ways to actually mitigate and remove carbon from the air.
I was going to say, while you're even saying that, is often what happens is people get interested in the topic. Then you start having this conversation. I think of this chain of custody of, wait, I have to look at the diesel that was used to ship the food onto the plane.
Yep.
They then immediately, they're like, this is too overwhelming. It's too complex. And it is. You can get stuck then in the don't do anything. Like I'm frozen in complete, I don't know where to go. Whereas if we just take a step back and go, there's lots of steps, there's lots of nuance, there's lots of logistics. But if we just keep it real simple, let's keep this real simple. We can clarify this issue, and I think this is what we're trying to do with this series and this conversation is we can get into the nuance, and it's interesting, but also take a big step back and go, but here we got to start Like, let's not get stuck in the conversation and stuck in the nuance and fighting about, well, if we cut the cost of the diesel by a little bit, like that's fine. But let's start doing it. Let's go.
Yes, and I think, Andrew, if you want to remove the nuance, if you want to get rid of all of the wiggle room for this sort of stuff, think about what I said earlier. How do we determine roughly what the impact of human beings is on the earth? Well, we can factor in all of the natural gas we pull out of the ground, all of the oil we pump, all of the coal we dig. If you're doing something on a human scale, on a corporate scale, on a national scale to reduce the amount of those materials that need to be extracted from the earth and are therefore consumed and converted into carbon dioxide, then you're doing something to solve the problem. If what you're doing is playing accounting tricks, that's not that helpful.
Yeah. And that's that greenwashing kind of conversation that we see.
Yeah, exactly.
Yeah.
Exactly that.
So what's your take on some of this? Like, what would be an easy way then to get this message across, and just specifically on this capturing conversation? Is it overall a net benefit, do you think, the captive technology as it's coming along, as it's being adopting? Do you see any space there where you're excited?
I do. I mean, on the carbon capture side purely, yes, I think there are places for it. I mean, first understand it has a cost associated with it. You know, at the U.S. Department of Energy would estimate that cost is around $50 a ton today. Now, $50 a ton, doesn't sound like a lot until you start to remember that it's 36.3 billion tons of carbon that's being emitted. And that $50 figure is actually at industrial scale in an industrial type operation. It doesn't account for some kind of magic machine that's going to sequester the carbon dioxide coming out of a motorcycle's exhaust, for example. That technology doesn't exist. So if you're looking to solve this problem through carbon capture, you have to start thinking about where you can apply this that is at the right scale and in an industry where a $50 per ton cost can be added without disrupting everything, without knocking everything over. And unfortunately, the answer to that today is there are not that many places I can come up with where this is a valid strategy. We'd like to see that carbon capture cost drop towards $10 a ton or even $5 a ton. And then you could apply it to, say, a coal burning power plant and probably not destroy the economy that depends on the electricity from that coal burning power plant. But we have other ways to deal with that coal burning power plant, maybe before we need to worry or wait for better carbon capture technology to come along.
Okay, so this is good, because I look at it then, okay, we've got an extra tool. We've got a tool on our tool belt that we can use. And once again, we can start utilizing it and we can develop it over time. We don't have to get stuck in make the perfect one for universal application. It's like, no, we've got a tool. We can use it. That kind of the next shift then, because we're kind of getting into it then, of this kind of, it was a term you came up with, the spark of genius. So if we look at energy generation then, and this is the core of it, because energy is wealth. Energy is your lifestyle. Energy is really key to any country. It's like the core of how to build a country. And we are, without a doubt, going through an energy situation, a lot of change, and it's a transition. What's it going to take? Where are we at right now? And let's give someone the straight up facts as to where we sit today with the energy situation.
Well, I think you've hit on the core of this whole problem, Andrew, which is if you have free energy, if you had all the electricity for free that you ever wanted, you can do practically anything. I mean, you could actually create in quantity, gold from lead if you wanted to. I mean, you could do alchemy if you had all the free energy in the world. Nobody has that free energy, unfortunately. And so the problem becomes, how do we generate the quantities of energy that we're used to? Because the quantity of energy that you have available to a society kind of determines the level of livability and comfort that you're going to have in that society. And so when you look at a country like Canada, Do we use a lot of energy? Yes. Do we emit a lot of carbon dioxide per capita? Yes. But we also generate almost exclusively green electricity. We have a large quantity of hydro. We have a fair bit of nuclear. We're doing things that are effectively quite green now in terms of generating electricity. Where things fall down are for societies like China, or to a lesser degree, India, but even the United States, even though they've substituted a fair bit of natural gas for coal, there's still an awful lot of carbon dioxide being generated for electricity that's being produced. And so you start to think about things like, we know the Chinese, for example, are building a lot of nuclear reactors, and we know that they're adding a lot of wind and solar. But if what they're looking for is reliable electricity, and I hate to tell people who are on an environmental kick this, reliable electricity does not come from wind or solar. Okay. And then if you start talking about, well, we can make it reliable, we just have to attach gigantic lithium batteries to everything.
Yeah.
Congratulations, you've added so much cost to the system that
Yes.
none of us will be able to actually use that energy.